Chapter 2. Neurobiology of Joy, the brain as a joy-generating organ. The human brain is, among many other things, a joy-generating organ. This is not a metaphor or an aspiration. It is a straightforward description of one of the brain's fundamental biological functions. The neural circuitry dedicated to producing, sustaining, and learning from positive emotional experiences is ancient, evolutionarily conserved, and exquisitely sensitive. It did not develop by accident. The brain's capacity for joy is as purposeful as its capacity for fear or pain, and understanding its architecture is the first step toward understanding why joy works the way it does, why it feels the way it feels, and why some people find it so much more accessible than others. The primary neural system involved in joy is the mesolimbic dopamine system, sometimes called the brain's reward pathway. To understand this system, it helps to begin with geography. Deep in the brainstem sits a small but extraordinarily powerful cluster of neurons called the ventral tegmental area, or VTA. These neurons produce dopamine, a chemical messenger, and project their axons, the long tendrils that neurons use to communicate, forward to a region called the nucleus accumbens, located in the basal forebrain. The nucleus accumbens is sometimes called the brain's pleasure center, though this description is, as we will see, somewhat misleading. From the nucleus accumbens, connections extend further forward to the prefrontal cortex, the brain's executive center, where dopamine signals are integrated with conscious thought, planning, and decision-making. This entire network, VTA to nucleus accumbens to prefrontal cortex, forms the backbone of the brain's reward system, and it is at the center of every joy experience that has ever been felt by any human being who has ever lived. Wanting versus liking, the critical distinction. One of the most important discoveries in the neurobiology of joy, and one of the most counterintuitive, is the distinction between wanting and liking. These two experiences feel so closely related that we tend to assume they are driven by the same brain systems. But pioneering research by neuroscientist Kent Berridge and his colleagues at the University of Michigan revealed that they are not. The wanting system, the anticipatory drive toward a reward, the motivation to seek something out, is primarily driven by dopamine, produced in the VTA and distributed across the mesolimbic pathway. The liking system, the actual pleasure and joy of receiving and enjoying a reward, is driven primarily by a different set of chemicals. The opioid system, particularly the mu-opioid receptors concentrated in specific hedonic hotspots within the nucleus accumbens and, to a lesser extent, the ventral pallidum and parabrachial nucleus. What this means in practice is that the anticipatory excitement you feel when something wonderful is about to happen, the dopamine surge of wanting, is neurobiologically distinct from the warm, glowing, embodied satisfaction you feel when you are in the middle of a joyful experience, the opioid-mediated glow of liking. Both are components of the full joy experience, but they are chemically and anatomically separate, and they can become decoupled in important ways. Addictive behavior, for instance, is characterized by a ferocious wanting system that has become entirely disconnected from genuine liking. The person craves intensely but derives diminishing actual pleasure from the thing craved. Understanding this distinction helps explain why the relentless pursuit of pleasure so often fails to produce lasting joy. We are activating the wanting circuit without reliably accessing the liking circuit, and the two require different conditions to operate well. The prefrontal cortex and the experience of joy. The prefrontal cortex, the large, wrinkled expanse of neural tissue at the very front of the brain, plays a crucial and sophisticated role in the experience of joy. It is the seat of what psychologists call executive function, planning, decision-making, impulse control, and the integration of emotion with cognition. In the context of joy, the prefrontal cortex performs several essential tasks. It receives and interprets the dopamine signal from the mesolimbic pathway, giving it conscious meaning and integrating it with memory and expectation. It helps regulate the intensity of joyful states, dampening them when social context demands restraint, amplifying them when circumstances feel safe and celebratory. And crucially, it is involved in what neuroscientists call top-down regulation of emotion, the capacity to consciously direct attention in ways that either facilitate or inhibit emotional states. Research using fMRI, functional magnetic resonance imaging, a technology that maps which brain regions are active during different tasks by tracking blood flow, consistently shows that positive emotional states are associated with increased activity in the left prefrontal cortex, particularly the left dorsolateral prefrontal cortex. Neuroscientist Richard Davidson at the University of Wisconsin-Madison pioneered much of this research, finding that individuals who habitually report higher levels of positive affect, positive feeling states, tend to show greater baseline activity in the left prefrontal cortex compared to the right. This left-right asymmetry in prefrontal activity appears to be both a marker of trait-level positivity and, importantly, trainable. Davidson's research on long-term meditators showed that sustained contemplative practice shifted baseline prefrontal asymmetry toward the left, which is to say, toward greater joy readiness, in measurable, lasting ways. The anterior cingulate cortex, where feeling meets thinking. A less commonly discussed but deeply important region in the neuroscience of joy is the anterior cingulate cortex, or ACC. The ACC is a curved strip of neural tissue that wraps around the corpus callosum, the bridge connecting the brain's two hemispheres, and sits at the intersection of the limbic system, the brain's emotional core, and the prefrontal cortex. Its position is not accidental. The ACC is functionally a bridge between feeling and thinking, between the raw emotional signals generated by the deeper limbic structures and the cognitive processing performed by the cortex. During joyful states, the ACC is actively engaged in integrating these two streams of information, producing the characteristic quality of joy as an experience that is simultaneously felt in the body and understood in the mind, an emotion that arrives with a sense of rightness, of meaning, of things being as they should be. The ACC also plays an important role in conflict monitoring, detecting when things are not going as expected, when errors occur, when the world does not match our predictions. In joyful states, this system appears to quiet, which may partly explain the quality of ease and openness that joy produces. When the brain's alarm systems are at rest, attention can broaden, creativity can flourish, and social engagement becomes easier and more natural. The ACC's reduced conflict monitoring activity during joy states may be one of the neural mechanisms behind Barbara Fredrickson's broaden and build theory, examined in depth in Chapter 5. Neuroplasticity. Joy changes the brain. Perhaps the most consequential finding in the entire neurobiology of joy is this: repeated joyful experience literally changes the physical structure of the brain. This is neuroplasticity, the brain's capacity to rewire itself in response to experience, and it is not a metaphor. When neurons fire together repeatedly, the connections between them strengthen. The synaptic gaps between neurons, the tiny spaces across which chemical messages are transmitted, become more efficient. The dendrites, the receiving branches of neurons, grow and become more elaborate. New neurons can even form in certain regions, particularly the hippocampus, a process called neurogenesis that was once thought impossible in adult humans but is now well established in the scientific literature. What this means for joy is profound. Each time you experience genuine joy, you are not simply having a pleasant feeling that will fade and leave no trace. You are participating in the literal remodeling of your neural architecture. The circuits that generated that joy become slightly stronger, slightly more sensitive, slightly more available for future activation. Over time, with repeated experience, this produces a brain that is genuinely better at generating joy, more responsive to joy triggers, more efficient at sustaining joyful states, more capable of recovering quickly from negative states and returning to positive ones. This is not wishful thinking. It is the mechanism by which contemplative practices, gratitude training, positive psychology interventions, and sustained exposure to beauty, play, and connection produce measurable, lasting improvements in emotional well-being.